Hello and welcome to our webinar on DevOps best practices and tooling. My name is Ross Beard. I head up marketing at Shadowsoft, and I'm really excited for you to be joining us today to learn from Shadowsoft's VP of Technology, David Rodriguez. We will be spending the next 20 minutes or so going through some of David's ideas. I encourage you to ask questions using the chat pane on the right, but we will be answering these questions together at the end. So before I hand it over to David, I do want to say a special thank you to our sponsors, Red Hat. We have been a Red Hat partner for going on 10 years, providing services and consulting around Red Hat's OpenShift product and Ansible product. All right, so David Rodriguez is Shadowsoft's VP of Technology. He's been on board for 3 months now, and prior to Shadowsoft, David successfully led organizations such as Intercontinental Hotels Group and Fiserv through their technology transformation journey. Now, David leads Shadowsoft's engineering team focused on helping clients prepare for the challenges of tomorrow and expanding Shadowsoft's capabilities around DevOps and organizational transformation. Without further ado, I'll pass the mic to David.
Thanks, Ross. Okay, so folks, today we're going to talk about DevOps, and we're going to talk about some best practices and some tooling. And these are based on personal experiences and conversations I've had with other folks that are doing this kind of stuff. So today we're going to talk about some core DevOps practices. We'll talk about why continuous is important in the DevOps model. We'll look at an overall big picture of DevOps. We'll talk about tools and types of tools to select. And we'll also talk about some examples of good and bad DevOps tool chains. So here are the core practices. And these core practices were developed in conjunction with folks I've worked with and engagements I've done. But really, these are things that most DevOps models have. And they may be called something different in other models, but here they go. So configuration management. We want to be able to track and manage the different configurations that we're developing in. So that way, as I'm deploying my software, I can deliver multiple configurations all at once and manage multiple configurations all at once. And that allows me to have a lot of flexibility, allows me to not be stuck doing one thing at a time, but it also allows me to be able to multitask, if you will, with my software and my testing. Continuous integration is the next one. Continuous integration, really, as we get new code developed, we want to be able to put it into our system and get it deployed to folks or to environments that can use it. So the continuous integration piece just means as my developers deliver code, we're going to put that code in a place where someone can use it. And it's going to be integrated with the efforts of other folks that are doing their software. So that's the continuous integration piece. Continuous automated testing. For me, one of the biggest things that helps us do DevOps better is the continuous automation testing. That means as soon as code is written, we want to test it. We want to make sure that we have valid unit testing in place because that allows me to test from the first line of code. And then, as I get into my build process, I want to do more testing there. As I get into my post-build processes, I want to test there. So I'll have things like automated smoke testing, things like automated functional and regression testing, and performance testing, load testing, and things of that nature. So, but the testing happens all the time so that as we progress through the software delivery process, we're always testing and we can always detect when something happens. Infrastructure as code is really important because that allows me to store my various configurations off in a code repository in the same manner I would my code. So that makes it easier for me to then pull those different configurations out and deploy them. So by having infrastructure as code is one of the principles That gives me the ability to test broadly, to test widely, to deploy broadly and widely. And again, it allows me to do a lot more at the same time with great repeatability and reliability. This helps reduce risk, it helps improve quality overall, so those are things that we want and why we put our infrastructure and treat it as code. Continuous delivery is important as well. As we go through a modern DevOps model, we're always running a machine. So code comes in, it gets tested, it gets validated, and it's continuously delivered to one of the destination environments. This lets me, as a delivery organization, always have something being put out there for someone to examine. And if I'm doing continuous automated testing, that testing needs something new to test against. So it has to have new stuff on it. So the continuous delivery gives me new stuff to examine and evaluate. And that helps me prevent having to catch up at the end of a release cycle. So that's what continuous delivery is all about. And continuous deployment is, similar to delivery. I need to be able to deploy to my target environments on a continuous basis. So as I get my code delivered, I need to be able to deploy to the various environments that I'm storing in my infrastructure as code. And being able to deploy on a continuous basis is one of the core DevOps practices, because it lets me put new things in different environments, like I might have a UAT environment that I want, or a staging environment. So as I complete a task, the continuous nature allows me to go in, in a nonstop method. So that's the continuous deployment piece. And then, as I'm working and progressing, I want to monitor what's going on. So continuous monitoring is important because it allows me throughout the development process to detect variation in performance, for example. So if I've got a system that requires a certain level of transactions per second or a certain level of screen refresh in order to meet our requirements, the monitoring helps me find that. So, as I'm testing, I get a new build, I test that build, I run through some various non-functional requirement tests, and I can monitor and detect that, hey, look, the last build I got suddenly slowed things down, so I'm not able to handle the same level of load, or it takes a lot longer to do what I'm doing, from transitioning page to page. So the continuous monitoring helps me detect that quickly. So here's a couple examples. As we go through our continuous model, we're going through the typical software development stages of plan, create, build, test, release, and deploy. The continuous integration piece kind of overlaps the plan and create part. And, as we're integrating, we want to make sure that we're testing each code change as early as possible. So, developer checks code in. We have automation in place that looks at the code repository where the code is checked in. We pull that code out, we build it, and we test it. And we test it during the build process. So, part of this continuous model requires us to have unit testing in place, and the unit testing is something that's automated, and it's something that's run automatically during the build. So that's really important for us to have this model working. The continuous delivery piece, again, as we mentioned earlier, we want to deploy everything as soon as it's ready, and we want to have a continuous stream of new things to look at as we go through the development process. So, once we have a good build, and once we've examined that build and it's good enough for us to move forward, we want to deploy that build. So it's a continuous thing that happens all the time. And then the continuous release, the ultimate destination for our DevOps models is for us to be able to release continuously and ideally to a production environment. Now that's the most advanced and most mature stage of DevOps implementation. So we want to be able to get us to where we can continuously release software to production without having the hands to intervene. So the DevOps model that I like to work with is drop code in, test it, evaluate it, validate it, and get it out to a production environment, or at least a staging environment. And that's how companies like Amazon and others that are doing thousands of changes per day are able to do that, because they have little bits and pieces that are always being delivered, and then they can get to production without impacting other things. So here's kind of an overview of the big picture, and the the pipeline that we like to look at is starting with our automated build. So we have a mechanism where we advise in the Agile space. So the Agile space, if we're doing storage correctly, work is being produced in small bits and pieces. And as part of the definition that's done for that work, we want to require that we have some automation in place. So that would be from the software perspective. So that means unit testing would be delivered with code. Once code is checked in, we have an automated build that is looking at the repository. So for an example, perhaps we have Jenkins looking at my Bitbucket repository. Jenkins detects the change, it pulls the change out, and it builds that change. And that set of code is then built and it's analyzed. So you see that we've got an automated build, and we kind of look at it. If the build doesn't work, we have an issue and we send it back. If the build works, during that build, we want to look at the code and make sure it's meeting standards. So we have this code analysis piece, and many things happen during that code analysis piece, but three that I always use in my DevOps models are, I always want to do and ensuring that all of my unit tests are executed and run. So, when they're run, they must pass. If any of them fails, they send the code back. But also, I'm looking for code coverage. A lot of new code, when I work with a company, we'll do an 80% coverage amount. So we want to make sure that any new code that we're delivering, the software developers have also put in unit tests to cover at least 80% of that code. That way we know that we have good testing going forward. As we get more mature in our implementation, we'll put things in place that will cause the build to break, and anything that's lower than our agreed upon threshold will get sent back to the delivery team for rework until it's got that amount fixed. So that's an immediate response to evaluating the code. So we want to do unit testing evaluation. A second thing doing the code analysis, we'll do security vulnerability checks. Tools like SonarQube and others allow me to evaluate the code as it's being built and identify any kind of low-hanging fruit in terms of security vulnerabilities. The reason we want to do that now during build is because it's the earliest point in time that we can independently detect vulnerabilities and send it back to the delivery team. That way, if my developer is giving you code today and I find that security issue this evening, that can go back to them. They can fix it tomorrow so that then the build can go forward. So security testing is the second thing. And the third thing is, a lot of companies have coding standards. We want to make sure that during the build process, we're evaluating the code and comparing it against the company standards. And there are violations that will be detected and marked as, hey, these lines of code failed to meet the standards. And if there are more than allowed based on threshold rules that's set up with companies, that code goes back to the developers to get fixed. And that might mean they just need to put new comments in the code, or they need to restructure the code so it matches the company standards. But by having code that is of a structure that is allowed by the company, then that code is more maintainable, more reliable, less fragile going forward. So those are the things that happen during the analysis phase. Other things can happen during this, but those three for me are bare minimums. So let's assume now we have a good build. Assume that our code passes all the analysis. I usually like to go into an automated deployment. So my pipeline will say, okay, build passes all the analysis. Deploy me a simple environment and do some smoke testing. And the smoke testing is going to be automated. It's going to be focused on ensuring that core functionality works. So it might be considered my MVP, my minimum viable product, or it might be a set of requirements that the company's given me that say, these 15 things have to work before I can push this code forward. So I make sure as soon as I get a new build that it meets those bare requirements or the minimum requirements so that I can push it forward. If any of my tests fail at this smoke test phase, that build is considered to be broken, and again, I send it back to my delivery team for rework, and then we start the process over again. All of these things are considered part of my development cycle for me. Until I have a clean build with good analysis that passes all my smoke tests, I don't push that build forward. And you can see in the picture here, we have all these inspections. So at each phase, we want to check to make sure that we pass the requirements for that phase before going forward. Once I have a good build, then I go into an automated deployment mechanism that allows me to deploy my now built code into one to many environments. I always have a functional regression environment. I may have a performance environment or a security environment or a UAT environment or a demo environment. So once I have a good build that meets minimum requirements, that build can be pushed forward to have examination in a bunch of different areas. And so, on the model here, I've got that one. I want to do continuous regression testing. So in this case, what I like to set up is after my build's complete and it's marked as good, I want to put it into an environment that's already set up that's similar to production. So it's production-like, and it's got all of my existing testing being executed in that environment. And I run those tests on a continuous cycle. And I've found that by running tests on a continuous cycle, I'm able to detect issues or regression defects immediately, within, however long it takes me to run the full suite. So if I've got a suite that takes 3 days, within 3 days I'll know that either I've passed all my tests and this new build is good enough to go forward, or I caused an issue with one of my existing tests that failed, so I need to do some investigation. But I find that out pretty quickly. And the reason I started doing this was way back when in one of my companies, we would find a bug, the bug would get fixed, we'd test the fix and move it forward, but not really test that bug again until we got to our hardening phase, and we found that same issue again. So, and that was, for that one instance, it was 3 months later. The developers have moved on, and the testers have moved on, but now we're going back and fixing things I already fixed because we didn't have that testing being executed all the time. So the continuous regression model is really important for making sure that as you progress, you don't forget to test the things that work already. That way we don't ever have to go backwards. We're always going forwards and always adding to our test suite. So after testing, you can see there's another inspection here. I want to make sure that all my tests pass. For anything that failed in this case, I typically write a defect, put it into my tracking system, and it's treated like any defect that comes in from a customer. We'll take the defect and meet with a defect review board, for example, that's made up of the business owners, of the product owners, development and quality, and we'll decide if that's an important defect that has to be fixed now, or if it's something that gets to be pushed forward into the next release. So there's some decisions there. After the regression, to make it look linear, we went ahead and put performance and security here. These tests can be run simultaneously, and you can see, this automated deployment, I mentioned, you can push stuff to multiple areas. So there's usually a full-blown security analysis that's done some point in the delivery or the development process. This might be with an external tool like Fortify or AppScan. It could be with an internal team, like an internal pen test team that's looking at this, but there's always a full security test of the code as it nears completion. That's what this little lock represents. And there's always some non-functional or performance testing that has to happen. In one of the companies I worked for, this was an independent group that did this. So they would get our near complete code, they would run through all their non-functional tests and their performance tests to make sure they were meeting standards, and they had the same mechanisms in place. So if something failed, either in security or performance, we'd write a defect, put it back in the backlog, and determine as a business unit that this was either important enough to stop the build, stop the release, or if it could be put on the backlog for resolution later on. But having the continuous model allows us the flexibility to make these discoveries and be able to still continue without stopping production of the software delivery. That's part of the DevOps model. So let's look a little bit at the continuous integration. And I probably have already mentioned all the things that we're going to talk about here, but At a minimum, automated builds. And, for me, automated builds can happen anytime you want, but at a minimum, you want to do at least one build per night. And the build will be able to be triggered on demand if we want. And, failed builds send out notifications. So I mentioned on the previous slide, my automated build really has one function, and we need to make sure that we can build. If the code doesn't build, it's a failed build or a build break, and we send it back. And the team that gave us that build is responsible for fixing that. In some of my advanced teams, what I would do is I would stop anyone else from being able to build and deploy until that one failed build fixed, so that there's kind of a peer pressure on that team that broke the build to fix the build, so that everyone else can get their builds out. That created some rivalry and camaraderie, and we had mechanisms in place that made people, slightly embarrassed to have the build break on them. But there's lots of things we can talk about for that. But anyway, so good build means now we go into automated code analysis, and we mentioned before that's static code analysis to make sure code and standards fit, unit test analysis to make sure that all the unit tests pass and we have appropriate coverage, and then security analysis to make sure we don't have low-lying security vulnerabilities. All those have to pass before we get into our smoke test. Smoke test is typically dropped into an automatically deployed environment that we predefined, stored as infrastructure as code. We run against whichever final build we have at night, and all tests have to pass. Any failed test is a build break, and any failed test is communicated to the team. So a lot of times I've got folks working both onshore or offshore, so I'll run this automatic smoke test and the automated analysis with that one build we decide is going to be our build for the day. And that build has to be kicked off early enough for my teams offshore. For example, I have folks working on the West Coast. They had to get that thing started and finished within 6 hours max, because that's when my India-based teams would start. So most of these in current, modern software, they can happen in less than an hour, but, that was my target for my builds then. And anything that fails, again, it's a build break. We send it back to the team that gave it to us, and then we go from there. My continuous delivery, it's based on automated deployments. It's based on having predefined tests. And so once I have that good build from the previous step, and I know the areas and the environments I need to deploy, and, for a QA group, for example, I might have, 5 browsers and, 5 different OSs I need to test those browsers against. So I need to be able to have those environments defined and have this code automatically deployed to those environments, so then I can run my continuous regression tests. So, the continuous delivery piece of those environments is really important, so that, I can deploy to the environments without having to, do them by hand. It's all done automatically by the machines. And then I have my tests already defined in those environments, so I can run my tests. And then I can detect issues or errors, report my defects, and, that allows me to have, first of all, shorter testing cycles, and then also, it allows me to have shorter hardening cycles when I get to the end of my release. Because I'm doing everything in an automated fashion, I know what I'm expecting. I know that if these things pass, I've got good quality built in, so I can be very predictable and very reliable. I know quality is in there because everything that the business requires for me to be able to deploy has already passed. I know that everything that operations or development needs has been passed. So that's my automatic deployment continuous regression piece. The security and performance testing, again, these tests are predefined for the most part. So anything that I've got automated, I run on a continual basis. And that really helps me reduce the risk of missing important issues. For security, it's really important. I don't want to miss something. So I automate everything that I know must be in place, and I've got compliance things that we can throw in here. And, we've got performance things. So I need to make sure that page transitions or page refreshes happen in a certain amount of time. or that I can handle processing a volume of data in a certain amount of time. These things are all predefined in tests, and we run them on a continual basis. During a larger release, we'll run them maybe once or twice. And smaller releases, they get run daily because, we might want to release and deploy on a daily basis. So, but predefining all these and having everything automated is really important for this to work. All right, so there's a lot of things that we just covered. And for us to make this work well, it really hinges on a good selection of tools. And so let's talk a little bit about some of the things that we need to, select your tools. So as I've gone into different organizations, there's always a challenge. Customers don't call you when they're happy and everything's working great, right? So typically it's a conversation with the CIO or the VP of technology in one of the areas that has a problem. So we go in there and we start talking about, what are the problems you're trying to solve? And, as we go through the conversation, we usually do some sort of assessment, and it's an investigation of the overall environment, the tooling, the technologies that they have in place, even the people, to see what's missing and how we can fix that, and then we kind of build a roadmap. And once we have a roadmap in place, we look at the tools that the customer has, and they may have 20 things that they need to put in place, and they may have tools that cover 8 of them. So we've got a gap of 12 areas that we need tools for. So after we identify the tools that help, we'll look at those gaps and identify those gaps and how we can fill them. And then we build a roadmap and we build a solution set that implements those tools together in a DevOps tool chain. So that's kind of the selection process. It's going to be different for every company. And if you've seen things like the ZDA Labs periodic chart of DevOps tools, there's tons of tools that can be used. We'll go in and, I always look at what the company has, and, they might have a really good automated build mechanism, but nothing for automated testing. So, I focus on that and get that in place. But this is kind of the process that we go through to start identifying what's missing and go from there. This process of assessment can take anywhere from 1 to 2 weeks to 5 to 6 weeks, and then the implementation of the solution depends on how much we have to put in place, but it can take a few months to 18, 24 months in some cases to get it right. So that's how we kind of go through some of the tool selection. So here we go. After we have our tools, there's always some standards for good tool chains, bad tool chains. So here's some really high-level principles. Good tool chains allow me to, do what I need to do in a amount of time, right? So if I want to have an automated build and then run through automated testing and get a potential build that can be releasable, I need to have enough time to run through the entire tool chain before I start over. So if I've got a build that is being activated every 2 hours, but it takes me 4 hours to do the combined work, I'll never get through a full sweep of that test or that build and test and deliver, because it's just running too frequently. So the tool chain needs to be sensitive to the amount of time it takes to do all the steps involved in the tool chain before starting over. So a good one allows me that time. As we get into more containers or microservices, the amount of time it takes to test and deliver is really small. So we can have multiple deliveries per day happen all the, on a continual basis, because we're looking at really small pieces of stuff that we're delivering. If we're looking at monolithic applications, it's almost impossible to get through a full run of the testing or a full delivery of the code because it just takes too long. So, that's really not an application conducive to DevOps until we can break it down into smaller chunks. But, we want to be able to get things done fast and get to a point where we can deliver fast and make that decision on whether or not this code is good enough to go forward fast. So that's a good tool chain does that. A good tool chain gives me the information I need to make a decision of fitness for release. If I don't have enough test data, if I don't have enough confirmation that the minimum viable product requirements have been met, I don't have enough information to make that decision. No, and I might have a pipeline and testing that it might all pass, but it doesn't tell me enough either, because the test might be focused on one area of the application that's really less important than other areas. So it's important for me to make sure that my tool chain is looking at the right areas, the areas that are most important to the company. And one thing I've used for fintechs is follow the money. Anything that touches money, we got to make sure that that is working correctly, so that we don't mess up the money. So I need to make sure in that case that I can tell if I put a transaction in, it goes through all the different transformations and calculations, that the end result of that transaction is correct, so that I can make that decision. Or if I'm looking at compliance, I need to make sure that my PCI compliance has been validated before I can go forward. So those are things that I need to be able to make decisions of whether or not this build is ready for release. And a good tool chain, customers make requirements or defects happen that have to be fixed. So a good tool chain should allow me to pivot on the fly. Meaning, if I've got something that's really urgent, I should be able to insert that into my pipeline, into my tool chain, and get it through the system. Use my existing testing and get that change out on the fly, if you will. It's kind of like an off-cycle requirement or an off-cycle test that has to be put in place. My tool chain should be flexible enough to take something that was not planned through the entire pipeline, to test it, validate it, make sure it's meeting the requirements, and be able to get it to a deployment place on the fly. And then really for me, the most important thing is, we talk about testing and moving to the left. We want to find problems as far left as possible. The reason we put in automated builds and automated unit testing is to make sure that we find issues immediately to the left. So that way, if my developers are writing code and we find defects there, it's a lot cheaper and a lot easier to fix a defect found during the build process than it is to find and fix a defect that's found during my final hardening testing or during a final security testing from an external group. So we want to find problems as far left as possible, and the only way to do that is using automation as part of our DevOps pipeline. And there's some bad things too, So bad things I mentioned earlier. If the tool chain is too frequent and it does not allow me to get through an entire suite of my testing or entire start to finish of the pipeline, it's not going to let me do the testing I need to prove that I can put this code out in production. So if things are too frequent, that's one example of a bad tool chain. Also, it could be too sensitive. A lot of security tools, as you first start using them, they're too sensitive, meaning we need to train the tool to understand our specific unique environment, so that then the false positives are weeded out, and the failures based on those false positives are weeded out. In the same vein, my regression testing, if it's too sensitive and not testing the right things, it might create false positives as well. And, that means there's communication requirement between my product owners, my business owners, and the developers and the testers to make sure that I'm testing the right things and I'm not failing on things that really shouldn't be failed on. So sensitivity is really important. And then the converse of that is too loose. If I don't have the right set of testing or the right set of criteria in place, and I'm not looking for all the things I need to, I'm too loose and I'm not sensitive enough to find major defects or major security vulnerabilities. And that will let defects into production, and then that creates unhappy customers, which we don't want. We want customers to be happy. We want them to be delighted. And that's why we put these things in place. And so, if I kind of summarize this whole DevOps model, I can summarize it by looking at some things that happen at, one of the companies I work for. I came in and they said, look, we have too many defects, our customers hate us. And even if we get code out, we don't know when it's going to be done. It's very unpredictable. And when I do get it out, I've got so many defects, and my customers don't trust me. And even the ones that do won't put it in production because we've kind of burned them so much, so we had poor adoption. So we looked at all the different things that needed to be in place, and the automation and the infrastructure as code and the things that we talked about in this talk today really were the things that were foundational to give me a reduced risk and greater predictability, and resulting in more efficiency in my delivery process, resulting in happier customers because they weren't getting defects anymore. And so that really allowed me to have better adoption, and the DevOps model in that case really helped us get the organization into a position where the customers were actually looking forward to our releases and would adopt them quicker, and we weren't getting any defects. We weren't getting complaints from the customers because we were finding them all as far left as possible. So that's why we do this. So today we talked about the 7 core practices, why continuous is important. We looked at some tool selection and examples, and now we're ready for some questions, I think, right? Or Ron?
Yeah, thank you, David. Appreciate it.
Absolutely, thank you.
Before we head over to the Q&A, I did want to communicate an offer that we have for you today. If you are having challenges with your software delivery, if you want to improve the speed of your delivery or the quality of your delivery, we have a DevOps assessment, which David and his team can take the lead on and help you with. What's involved here is we'll perform a discovery on pre-existing DevOps automation tools and processes. We'll assess integration with your existing DevOps tool chain, really talk through what David discussed earlier around finding the right tools based on what you're currently doing and what gaps you have. And then finally, we'll deliver an assessment report detailing current environment, gap analysis of capabilities, and recommendations for improvement. So if you're interested in this, make sure you send us an email at contact@shadow-soft.com. Okay, that's enough from me. Now I want to pass the mic over to you guys and girls. What questions do you have for us? Use the chat pane to the right. And I'm going to welcome David back in here, and we'll answer them together.
Howdy.